Okay, so it's now our 10 minutes is gone. Hopefully not too quickly, but we should continue here. There was one question I received uh, in the Zoom chat that was sent directly to me, so you all didn't see it, but it was a useful question to address. So I think one thing about for loops just before we move on. So we've seen here we have these two lists of odd numbers and even numbers, and then we have our for statement that's allowing us to go through and add them together and print this out. Now, it is sometimes the case that you want to exclude some values from what you're doing if you're dealing with two lists. So like, for instance, we could imagine a case, I don't know why, but just, for the sake of demonstration, that we didn't want to add the last two values together in here, but only maybe the first three. Now, it's possible that you could just change your range function here to use the value of 3 instead of the len function there. And okay, then you would just see that you add together the first 3 values from the two lists. But another thing you can do is the len function just returns a number. So what you get from this function is just an integer value. So if you want to exclude some values, you could just, for instance, subtract 2 from the length of the list that you get back. 5 minus 2 is going to give you 3, and you get the same result that way. So if you want to exclude just the last value, you could take your len minus 1 and get everything but the last value. Of course, if your len is 0, so if you take length 5 minus 5 and you get range 0, then nothing happens because the collection that you've given has a length of 0, so the code doesn't do anything at all. But in that way, you can basically modify how many of the values that you're dealing with or want to deal with in your in the cases that you're considering here. So just as a quick demonstration to show how that's working. All right, so that's kind of it for loops for right now. We can jump to our other part of our lesson here on conditional statements at this point. So I'll open that up and I'll just hide the file browser again so that we have a little bit more space to see what's going on. So in this case now with the conditional statements, we're going to learn about if, we're going to learn about another statement called elif and else, and also we're going to deal with Boolean values. So these are true and false values in Python. So the basic idea in these conditional statements, it's basically a fancy way of saying if something happens, do something else. So the idea here is just if a condition is met, then a certain set of actions would be performed. So we can take a look at a very simple case here where we define a temperature, in this case 17 degrees, and we're going to write a code that will tell us whether or not 17 degrees is hot or not. And in this case, the basic construct is if some variable, and then here is a comparison operation. So if temperature is greater than 25, do this, print, it is hot. Otherwise, if temperature is less than or equal to 25 degrees, so it's not greater than 25 degrees, then you print out, it is not hot. I suppose this is somewhat subjective, but if you run this, what we see is sure enough, 17 degrees is not hot because when we do this comparison, 17 is not greater than 25. So this condition is false, which means because the if condition was false, the else statement determines what will happen at that point. So if this condition is not true, it's basically otherwise do this thing here. The idea, I think, in principle is not terribly hard to understand. It's basic logic, but of course, it's going to take a little bit of practice to become familiar with how to use this and how to understand and interpret these kind of conditional statements. But essentially, the basic picture is if, and then we have some condition here. So this is going to be some kind of evaluation, where we look at a comparison between values, for instance, and then determine what should happen based on whether that condition is true or whether that condition is false. So for instance, we could say, update our temperature to a hot temperature. This is something you could do on your own, you feel free to do that. I'm just going to copy and paste what we had from above down here, and we'll do this ourselves. If you want to work ahead of me, I would say do so quickly, because we'll take a look at this in literally just seconds from now. But essentially all you would do is, let's pick a temperature that is considered hot. I think all of us would be content to say 35 degrees is hot. And so if the temperature equals 35 degrees now, we do the same comparison we did before. Now this condition is going to be true. Temperature of 35 is greater than 25. That's true. So now we should see what we get as output is it is hot. And sure enough, that is what we see. So that's the basic idea. And the thing is, with these conditional statements, we don't always need to include an else statement. So we could, for example, exclude an else statement. So we have our condition here. So let's set our temperature back to being 17. And let's just do it like this. If temperature is, we'll do the same condition we had before, greater than 25, print, it is hot. And let's leave it at that. Let's not include the else statement this time. And what's going to happen when we run this code? Basically nothing. The code does get executed, but we don't get any output. The reason being that now we've set our temperature back to 17 degrees. We compare, is our temperature greater than 25? It's not. This condition is false. And all we've provided here is what to do if this condition is true. So when the condition is false, basically nothing happens. And that's a totally fine thing to do. There's a lot of cases, in fact, where what you want to do is just check and see whether something is true or not. And if it's true, then you want to do something and you don't care what happens if it's false. For instance, if you're checking to see, is a variable, within a range of numbers that's safe to use to continue in the code, is a file, does it exist? If the file doesn't exist, then maybe what you want to do is have an error message that comes up. But if it does exist, you might want to continue. So we could use this method to answer problem 2 from last week. What was problem 2 from last week? It's a good question. Let's have a quick look here at problem 2 from last week. So that was exercise number 2, and problem number 2, modifying the lists. No, that's still problem 1. Problem 2, monthly average temperatures, and we were asked, I think, to make notebook display the temperature of a setting selected month index, having it work for all the months of the year. Additional tests. I suppose I'm not quite sure where the conditional statement would come in this problem. And problem 3 was just about using Markdown. Well, I think it's not totally obvious to me where this would fit in, but for instance, you could, I suppose, if you're wondering about checking, for instance, whether the temperatures are hot or not, yes, of course you could do that. And what you would find is actually none of these months' average temperatures would be considered hot. It's not a huge surprise, perhaps, here in Helsinki. But yes, we can do things like check the conditions of different values that we're dealing with. Another example that might be a little bit more familiar to you is when you look outside. Of course, on a day like today, you're probably not asking the question of whether or not to wear a rain jacket, but rather to wear a proper insulated warm jacket. But in many cases during the autumn, you're going to look outside and say, should I wear a rain jacket today or not? If the weather condition is such that it is raining, then the decision you're most probable to make is that, say, if the weather equals rain, print wear a raincoat. And if it's not raining, then no raincoat needed. So you run this, and what you see is weather is set equal to rain. If weather equals rain, print wear a raincoat, and that's what we see output here. In this case, we're using this double equals operator. So this is checking to see that a value is exactly equal to another. So here we're checking to see if the variable value that's in weather is exactly equal to the character string rain. And in the event that it is in this situation, we're then seeing print wear a raincoat. Be aware that when you're dealing with comparing text strings, if you have an extra thing like a space here, rain space is not the same as rain without a space. And when you run this same code, you now get back no raincoat needed, because you've tried to compare this string where it's rain with a space at the end of it to a string here that is rain with no space, and those two are not exactly the same. And so this condition is not true, and you get no raincoat needed. There are a handful of different things you can do with character strings to try to avoid this problem. A common issue would be that you would have a code where perhaps you've defined a variable like this rain with a capital R. It might even be a program where you're sort of prompting the user for input, and they put in something with a capital R. And if weather equals rain in this case, similarly, you get no raincoat needed, because capital R rain is different from lowercase r rain. If we wanted to make this work for the case where someone puts in capital or lowercase letters, you could add in the .lower method. We haven't done this with dealing with strings, but you will perhaps see this in other places. Now we say we take weather and we make all of the values that are listed here lowercase and equals rain. Well, that should be the case. If we force this big R to be a lower r, lowercase r, now we get rain or wear a raincoat. And it doesn't matter if we want to, be stylistic and make this a capital I, whatever, it's going to be the same. It gets converted to lowercase. So there are ways to deal with these kind of problems, but just be aware when you're using these comparison operations, especially with character strings, it's case sensitive, and it's sensitive to having spaces in the variable names. And you have to then pay attention to what you've written. It's very easy, for example, to miss a space when doing these kind of things. Yeah, similarly to what we have for for loops, it's also the case that everything within these conditional statements, so if something is supposed to happen, it should be indented underneath that if statement. Same for the else statement. And again, they both end with a colon at the end. Otherwise, what you'll see is an indentation error. So why don't we, let's take a couple minutes here. Imagine that on this rainy day, you not only want to wear a rain coat, but you also want to wear rain boots. So how would you modify the example that we have above in order to generate this output if it's raining outside? So there's no poll question for this. Maybe just try and do this, and then why don't you go to the participants list once you've done so, and you can then add your maybe green check mark or something like that to indicate that you're ready to proceed. So all you're going to do is just modify what we looked at above to now say wear a raincoat and wear rain boots. And we'll continue in just a moment. Okay, so we are up to 16 now. Green check marks. Thanks for those who have added them. And I'll go ahead and just demonstrate how to do this just with the time in mind. So if we copy what we had above down to the cell here, we had this weather equals rain, and our basic task was to modify our output so it says wear a raincoat and wear rain boots. Now, if we want to be picky, we can remove the exclamation mark because that's been taken away from the earlier output. And all we need to do in this case is now, if the weather is rain, we're going to print out two different things here. So wear a raincoat, and then we'll also print out wear rain boots. So that's all it is. Everything that falls underneath this if statement will be executed when this condition is shown to be true. So if the weather is rain, then now we will print both of these things. Otherwise, we say no raincoat needed. And sure enough, when you run this, you get wear a raincoat and wear rain boots as the output. So the point being that you can, of course, have multiple lines that are executed inside one of these if statements, same way that you could with a for loop. Okay, now what we have seen in the last example, maybe I'll leave it up here just so you can see it again, is the use of a comparison operator. In this case, it was the double equals, which compares to see that a value is equal to another value. Like a variable is equal to a character string, for example, or you could compare two variable values. You might want to check and see the length of two lists is the same before proceeding in a code or something like that. There are a few different options here. So you can see there's a less than operator, a greater than operator, but there are also these less than or equal to, and this is how you would write that in this case, or greater than or equal to is written like this. And then finally, the one that we haven't seen yet is the not equal to. So sometimes you want to check and make sure a variable value is not equal to another one, and you do that with an exclamation mark equals sign for that comparison. What happens inside Python is essentially when you use these comparison operators, you get back either a true or a false value. This is a Boolean value if you want to talk the talk here. And so it means it's a value, it's either true or false. And in fact, the value in the sort of word true with a capital T and false with a capital F in Python is sort of a special value that you cannot use as a variable value, for example. So you can't assign a value to a variable called true. Now, if we want to just see basically how things are working, we had our variable from before called temperature. It's still equal to 17, I believe. So yeah, just run this cell. I see temperature is equal to 17. And I could say, for instance, temperature is greater than 25 and just run that. And what happens is Python evaluates the statement. Temperature is greater than 25. No, 17 is not greater than 25. So it returns a value of false. Similarly, we had our weather condition being equal to rain. And if we run this comparison, weather equals rain, what we see here is we get back a value of true. So this is how the comparisons are working. You're using one of these comparison operators between two values, and what you get back from that comparison is either a true or a false statement. Now, just to demonstrate, true is a protected word in Python. If you try to assign a value to a variable or to the word true, you're going to get a syntax error that tells you cannot assign to true. So it's not a valid variable name. Not that you would be likely to try to use it anyway, but just be aware that true and false are protected and cannot be used as variable names. Okay, one more thing we can look at here with our conditional statements is the elif statement. So we've seen if, we've seen else. So if, then there's a condition. If that condition is not true, then we would execute the else statement if things are written that way. But there's a third option, and that is elif. So if you have something you've checked for and say, if this condition is true and it's false, you can have a second test using the elif. And so elif in this case would say, okay, if the if is false, then what about if this is true? And so yeah, there's a question here in chat. I'll maybe come back to in just a moment. But essentially, what we want to do here is we want to say if the temperature is greater than 0, we can say that the temperature is above freezing. If it's exactly equal to 0, we could say it is freezing. And in other cases, we would say it's below freezing. So we have a temperature here of -3. And let's use some conditional statements to produce the output that we're looking for. So the first thing we can do is we can say if temperature is greater than 0. So that means it's above freezing. What we want to do out in that situation is, let's F string this. So we're going to print temperature is above, or well, okay, let's make it nice. So temperature degrees Celsius is above freezing. And so that's what's going to be printed if our temperature is above 0. Our Elif, so if this is not the case, our temperature is not above 0. With Elif, you're supposed to again give another condition that should be checked. In this case, we're going to say temperature exactly equals 0. And I'm just going to copy this to save typing it again. So now we have temperature degrees Celsius is, and let's say at the freezing point. And finally, if it's not greater than 0 and it's not exactly equal to 0, well, we know that that temperature must be below freezing. So again, I'm just going to paste what we had from above and say that temperature degrees Celsius is below freezing. All right, so here we have a first condition, are you above freezing? Second condition, are you exactly at the freezing point? And if neither of those is true, logically, it must be the case that the temperature is below freezing. So now we type this in, and what we see for the output is 17 degrees Celsius is above freezing. Well, the reason we see that is because I forgot to run the cell up here where we changed our temperature to -3. So let's do that again. Now our temperature gets set to -3. Now when we run this, -3 degrees Celsius is below freezing. Sure enough, that's what we expect to see. Now, if we change this temperature to be something like 17, as we just saw, and you run the two cells again, you get 17 degrees Celsius is above freezing. And naturally, if you set it to be equal to 0, the Elif condition should be true. In this case, 0 degrees Celsius is at the freezing point. So essentially what would happen here with this situation is temperature of 0 is not greater than 0. So that's false. Then it comes here, temperature exactly equals 0. Yes, that's true. And then we get that output printed to the screen. Now, quick diversion for just a second. Someone was saying in the chat that they typed in true plus 5 and got the value of 6. Return to the screen. And similarly, if you type in false plus 5, and you get the value of 5 back. It is the case that often these, the number equivalent of true and false is false equals 0, true equals 1. If we did the type conversion here to say int of true, I think this works. You get a value of 1 back. And if you do an int of false, you get a value of 0 back. When you try to put those things together, like false plus 1, true plus something, it implicitly converts those to be their integer equivalent. It was very common in earlier programming languages to use 0 for false, 1 for true as an easy way to check and see whether a condition was true or false. Another question here, is it possible to use Elif multiple times? Yes, it absolutely is possible to do that. So let's say, let's modify what we have here quickly. I don't want to use too much time because I should save a tiny bit for Håvard to present the exercise for this week. But let's imagine that instead of comparing things to being above or below freezing, we could think about like something being warm or hot. So we said before that above 25 degrees was hot. I'm just going to modify what we have here. So if the condition is that the temperature is above 25, it's hot. Let's add an Elif here and say temperature is greater than 15, I don't know. We'll take our same statement, copy paste it here, and we'll say it's warm. And then we'll say if the temperature is above 0, we'll say it's maybe cool. And then otherwise, we'll say it's cold. Okay, so just slight modification. So if our temperature is above 25, we get this. If it's above 15, we get that. If it's above 0, we get that. And finally, then, if it's none of these are true, then it's cold. So our temperature was set equal to 0 before. We run this. What should we expect to see here? Well, it's not going to be hot. It's not going to be warm. It's actually also not going to be cool because our temperature is not above 0. It's equal to 0, which means we should expect to see that our temperature is cold. And 0 degrees Celsius is cold is the output that we get here. If we make it 1 degree, and again, this is somewhat subjective, and we run the code again, now we get 1 degrees Celsius is cool. And we haven't bothered to make our program detect whether we're using the value of 1 to say if 1 degree Celsius is cool, but it just gives us the output that we have in this instance. If we wanted to, we could add in another Elif statement here to say if temperature is above minus, let's say minus 15. We'll call it cold. And then in this case, we can have an else to say, I'll just copy this, oops, put it here, and we'll say it's really cold if it's below minus 15. I think that's fair to say. So in this case, if we put in a temperature of, for instance, minus 9 and run our code, we see that minus 9 degrees Celsius is cold. If it's minus 19, we see that it's really cold. So yeah, it's absolutely possible to use multiple Elif statements. There are some arguments for why you don't want to have too many of these, but depending on what you're doing, especially classifying values, it can be very helpful to have multiple conditions like this to say, okay, is this true? If not, is this true? If not, is this true? And so forth. The thing that's important here is that the order may matter in how you do this testing. So we first check to see if the temperature is greater than 25. 25 is the biggest number we're dealing with. So anything that's not bigger than 25 will go on to these other tests. However, if we first said, is the temperature greater than minus 15 as our first test, we would say, oh, then it must be cold, even though the temperature could be 40. So the order in which the tests are done will make some difference if you have multiple conditions like this. So that's something to be aware of. The reason that I've done it in this way here is that we're always checking to see if it's bigger than some value, and the value we're comparing against is always stepping down, but it's always bigger than the next test value. So we're always sure logically that we're kind of like working our way down from the top and sequentially checking the conditions, and such that if none of these conditions are met, then this must be the case logically. You could easily rearrange this to make this look like a total mess and get all kinds of weird results from that. All right. Now, I think we have one little tiny thing. Yeah, we got a couple little things after this, but we have a check your understanding opportunity with a poll question. So let's do that next. Thank you, Hovard, for posting again the poll link to the Zoom chat. Let's assume that yesterday it was 14 degrees. That was a bit ambitious. It's 10 degrees outside today. I think it is supposed to get about there. Tomorrow it'll be 13, probably not. But whatever. These are typical fall temperatures here. Following code compares these temperatures and prints something to the screen based on the comparison. So yesterday equals 14, today equals 10, tomorrow equals 13. Here are a set of if and elif statements, and your task is to determine which one of the letters would be printed to the screen from the options available on the poll page. And I will put up the question here, and we will come back in just a moment once everyone has, 20 or so people have filled in their responses. Okay, very good. So we are up now to 20 responses to the poll question here. Let's have a look at what people think. So there's B and C as one possibility, only B, or some other combination. So there's 3 different options, although there's clearly one leader in this case here. The only B's has a solid lead out of the votes that have been cast. So the way that this is going to work is, in fact, yesterday, today, and tomorrow's temperatures will be compared. And if we go through from the start, yesterday less than today. So is 14 less than 10? The answer to that is false. So this would not occur, and you'd move on to the next test. Elif, today is not equal to tomorrow. So is today's temperature not equal to tomorrow? Yes, that is indeed the case. So you would get print B written to the screen. After that, the remainder of the tests would be skipped. So once you meet one of the conditions here, if there are elif statements after that, nothing will happen with those. So if we just copy this, as you may have done, and paste it into the cell that we have here, what you see is the output of B. If you were interested to check and see if each of these conditions are met individually, you would not do elif, but instead have separate if statements for each one. So if you want to know out of these comparisons which of them is true, you would modify this to not use elif, because if it elif, it relies on a previous test being false to then do that next comparison. Once one of those tests is true, the rest of the elif statements will be skipped, as well as the else statement. So looking at this, we have this additional test here, elif yesterday greater than tomorrow. Yesterday 14, tomorrow 13, this would be true. Today equals today. Well, that should also be true. And if we run this, what we see in this case, if they're all if statements independently, is B, C, and D are all true. But be aware, of course, in this case, the reason we only saw B was because we have elif conditions. So in order for these next tests to be considered, a previous test must have to be false. All right. One thing we have not covered yet is about combining conditions. I'll just demonstrate this quickly because it's something that is in some ways intuitive, and in some ways just takes a bit of time to kind of think through and practice, but I'll show you just an example here. So we have a comparison that is done here between 1 being greater than 0. I hope you can all see that that condition should be true, and -1 being greater than 0. That condition is false. We are combining these two tests using the AND statement. And you'll notice we've wrapped them both in parentheses. This is partially just to make it easier to read. It's when you put these sort of conditional statements inside a set of parentheses, it's very clear which things you are comparing directly. So if you have multiple or a longer statement than 1 greater than 0, it's very easy to see. This condition should be true. This condition should be false. And this is a logical AND operation. So what that means is that in order for this condition to be true, this has to be true and this has to be true. So in order for this if statement to be executed, both of these conditions must be true. That's why we can say, if that's the case, both parts are true, because this is greater than 1 greater than 0, -1 greater than 0. In that case, we have true condition and a false condition. And when you say true, then the logical AND operation, and false, what you get back is false, because not both parts are true. And in this case, what we would expect to see then is our output should be at least one part is not true. When we run that, sure enough, we get at least one part is not true. Just to demonstrate this a bit further, we could say true and true. That's basically what we're trying to check for here, is we have a condition. So let's imagine our condition here is true, the and statement, and then another condition that's true. If you run that, what you get back from that when you check for both conditions is that yes, true and true is also true. But if this is false, as is the case here in our example, true and false gives you back false, false and false also gives back false. It's a little bit weird to start thinking about things this way, but logically, essentially all we're doing is saying, are both of these conditions true? If so, do this. If either one is false or if both are false, then you do the following. Similarly, we have a comparison here that's using or. This is another way in which we can combine comparisons. So here we have 1 less than 0. That's false. Minus 1 less than 0. That's true. And we are comparing them with the or operation in this case. So what we know in this case is if either one of these is true, we're going to then execute the thing that follows. And we have false and true here. So one of the conditions is true. So we should expect to see the output. At least one test is true. And sure enough, that's what we see. At least one test is true. This or and operations are not used that often in what we're going to do in the course, but they are very powerful and useful things to do when you have to have more than one condition that must be met to continue, or at least one of these must be true in order to continue. If we change this or to an and in this situation, we should expect to see no output, which is in fact what we see, because we know that both these conditions must be true for this output to be generated, and one of them is not true. With the or statement, only one of the conditions has to be true, or both could be, but only one must be in order to get the output that we see written out to the screen here. And later on, we will use some other bitwise operators for doing these kind of comparisons with lists of values or arrays of values when we start dealing with the pandas library. So that's just a little bit about multiple comparisons. I think you have an opportunity to deal with that in the exercise for this week. So that's something to consider there. We have one more opportunity to check our understanding. I think I'll just walk you through this one so that you can see it. But basically, we had this idea of making decisions of what to do when it was rainy weather. And for some of you, rain might be like, yeah, who cares? It's raining. And if it's a windy day and it's not raining, well, that's fine. But if it's rainy and windy, you might be like, ugh, I'm not doing this. I'm just going to stay home. So there are different situations in which you might make decisions about whether or not you want to go out and do something. Especially if it's an outdoor activity, you might want to check multiple conditions before you make your decision. So we can imagine here that we have a windy day and a rainy day. And our windy day here, our cutoff that we're considering for our Navakatuli is 8 meters per second. The wind speed is actually 9 in this instance. So it's certainly above the limit of a fresh breeze. And what we want to do is, the test here says if it's rainy or windy, stay at home. I'm thinking we're not going to sort of let a little bit of rain or a little bit of wind bother us. But let's say if it's windy and raining, let's stay home. Otherwise, we can go out and enjoy the weather. Let's start it out like that. Okay? So we have our weather condition, we have our wind speed condition, and that's going to determine what happens here. So we will say if weather equals rain, and let's go ahead and wrap this in parentheses just for clarity. So if it's raining and the wind speed is greater than 8 meters per second, then we'll just print out just stay home or stay at home. Otherwise, if it's either not raining and not windy, or Oops, I got a little typo here. Got to close my quotation mark. So in the other conditions that it's either not raining, not windy, or both, then we can print, what was it? Go out and enjoy the weather. And that's our condition that we're looking at here. So in order for us to stay at home, what we're going to say is that we will allow it to rain or be windy, but not both. If it's rainy and windy, then we're going to stay home. Otherwise, we're going to go out and enjoy the weather. And in this case, it's raining, the wind speed is 9, and we run this, our code tells us to stay at home. If we had wind of 9 and it was sunny outside, run the same code, and we get go out and enjoy the weather. And similarly, put this back to rain and our wind speed back to something lower. If it's rainy but not windy, we can also go out and enjoy the weather. And surely if it's neither, then we can go out and enjoy the weather again. We could add an Elif statement in here to say like, wear the right clothing for the weather or something like that. But that's what we have here at the moment. Another way that we could approach this is to say that we're not really into being outside unless it's really nice. So it can't be raining or windy. Otherwise, we're just going to stay at home. So in that situation, we might consider using the or statement here to say that if it's rainy or windy, I'm staying home. Or if it's both, I'm staying home. But only if neither of these conditions is true will I go out and enjoy the weather. So if I run this now, like we saw before, when it's rainy and windy, we're staying at home. If we drop the wind speed down to 3 and it's raining, we're staying at home. If the wind speed was back to 9 and it's sunny out, we went outside in the last example, but this time we're staying at home. And only if the wind speed is low and it's sunny would we then go out and enjoy the weather. So this is up to your personal preference, whether you want to use an or an and statement here. Probably this won't be how you approach whether or not you go outside, but just as a matter of demonstration, you could do things in this way to be consistent about whether or not you go out and enjoy the weather. All right, so that's just how to combine conditions. The last thing here is that we can link together our for loops and conditional statements. So we have seen for loops now, we have seen conditional statements, and of course, we can combine them with a list of temperatures, for example. We could look at all the conditions in which the temperature is greater than 25 degrees and print out that that temperature is hot using a combination of for loops and conditional statements. So first, let's write a for loop. And we'll say for temperature in temperatures. We're only using a single list in this case, so we'll just take the values directly out of that list to work with them. We can then say if our temperature is greater than 25, then we print out that it's hot. And let's do it with an F string. So let's say that temperature is hot. All right, so that should give us the output that in that condition, our temperature is hot. Otherwise, if it's not hot out, we'll say it's not hot. So we'll just take our same print statement we had from above, copy that and paste it here. And we'll say it is not hot if the temperature is not greater than 25 degrees. So what this is going to do is it's going to loop over all these temperatures. So 0, 12, 17, 28, and 30. Each one by one will be checked for these conditions of whether it's hot or whether it's not hot. And then that output will be printed out to the screen. That's what we should expect to see here. If we run this, we get 0 is not hot, 12 is not hot, 17 is not hot, 28 is hot, and 30 is hot. So it looks like our code is working correctly, and we get the output that we expect to see here with a combination of a for loop, and then we indent everything that should be part of the for loop. In this case, it's 2 conditional statements. So we have an if condition And then, of course, everything that's part of the if condition is also indented. So one sort of step further indented. An else condition, and again, the indentation of the else condition there. And that's how we end up formatting a combination of a for loop with conditional statements. Do you have any questions at this point? I appreciate the questions that have been coming in the Zoom chat. That's great. So yeah, if there are questions about for loops and conditional statements now, I can answer those. Otherwise, we will take a quick look at our good coding practice for this week. And then I think Håvard will introduce the exercise for this week's lesson. So I'm not seeing any questions at the moment. If any questions come up in the time between now and when we wrap up the exercise preview, you can just put them in the Zoom chat and we'll come back to those at that point. But since we don't have any, I will stop sharing and turn things over to Håvard for the moment.
Yes, I will share my screen and then take a look at this week's good coding practices. So inside the notebooks folder for lesson 3, there is a notebook with this week's good coding practices, which is about writing readable code. So as the name suggests, we want to write code that is easy to read for both you when you come back to your code at a later stage, but also for people who haven't been writing that code as well. And this is when you're working in pairs. This is especially important because then making sure that the other person in your pair is able to understand the code that is written makes it much easier for that person to understand it and also work on the same code. So in the interest of time, I'm going to go a bit briefly over this, but as you have seen today, Python has some requirements for how to write your code. For instance, in the for loops and if-else statements, you have to indent some code for it to be part of that. So there are some restraints and requirements that you have to follow. But then there are also these guidelines that is called PEP 8. And you can, if you press the link here, you can read the whole set of guidelines, which is quite long. But we have summarized kind of the most important guidelines that relate to the course and the codes that we are using. So these are guidelines to make it easier for other people to understand your code, and also to so that you, when you have written the code and look at it at a later point, it's quick and easy to understand what you are doing and what you have done. So the first guideline that is important is a maximum length guide. So in order to try to make it readable, try to not make your lines have too many characters. So the PEP 8 guidelines suggest 79 characters to be the max for each line, and 72 for comments. So that kind of makes sure that if you're using a text editor or your window is smaller, then you are still able to see everything that is written on that line, so you don't have to scroll horizontally. And then, as we have been over today, indentation is an important measure to make the code easy to read, and that is for PEP 8, we suggest you use 4 spaces for indentation. That makes sure that all the indentations are the same, and makes it easy to lay out all the indentations after one another. Yeah. So here are some examples of using that. And then I'll go over to white spacing and binary operators. And as you've seen, white spaces can be important especially when working with strings. But for easy readable code, we suggest that you use a white space both before and after operator. So when writing assigning variables like here, I equals 1, having a space before and after the symbol is good practice. So both before and after here, for instance, and not like having I, no space, and then the symbol, no space, and then 1, or even using like in this case, I space plus equals 1 is kind of makes it messy and difficult to read, especially when there is more code than just this one example. And then also try to avoid having extra spaces where you don't need it. So to make it easy to read, keep it simple with, for example, when using a function like print, do not put a space before the parentheses, just print and then directly your variables or values that you want to print. And then the next one is to try to keep writing one statement per line. So you could make a working Python program with writing everything on one line and using the semicolon, for example, and have that take up all the way to the right of the screen. But that makes it very difficult to read. So a rule of thumb is to want to do one thing per line. So here we want to print hello, and then we want to print world. Then we put print hello, and then a new line, and then print world. And the same goes for instance, in the using an if statement, then you put the print temperature, what happens in the if this condition is met, put that on a new line indented. That makes it very easy to read. And then at some point you might end up in a situation where readability versus the length of the code might be an issue. And now this hasn't rendered properly, so you can look at that on the website quickly. But it's and we haven't covered list comprehensions in the course yet. But if you see down here, these are two options that will basically produce the same result. And this, you will come into some situations where the readability is a question of preference, basically. So here in the option A, we create a list that's called squares, and then we have a for loop that appends a value for each iteration of the value x in the range 10. So when you have worked with for loops, this is an easy to read code snippet, but the option B produces the same thing with a technique called list comprehension. So if you have worked a lot with list comprehensions before, then that might be easier for you to read. So, and both codes produce the same result. So at some point, sometimes this is an option of preference of what you find most easy to read. But when in doubt, you can check the PEP 8 recommendations and guidelines. So I advise you to go back to either this page and then also check the PEP 8 guidelines if you're wondering, is this actually easy enough to read and understand? Okay. So if there's not any questions about code readability, then I'll proceed to going through the exercises. So yeah, remember to, on our course pages, accept the GitHub Classroom assignment, and then you'll be taken to, once that is ready and up and running, it will take you to your GitHub repo. And so if you remember, we cloned this before using the URL here, and then in our Jupyter lab, going into our exercises and see that it's cloned here. So this week there are 3 mandatory exercises and then one 4th optional one. We can open the README first. So yes, the exercises are due before the start of the next lesson. And remember that to check your pairs for who is the driver and who is the navigator this week. Okay, we can start with the problem 1 for this week's exercise. Sorry, all these exercises are about the for loops and conditional statements that we've been through today. So in problem 1, we'll be working with a list of data files that we will be iterating over in for loops. So yes, we have in many cases we have a lot of data files on our computer that we need to process, and then iterating over a list of the file names is one option to efficiently either read all the data files or edit them or use them. So the first exercise problem 1 is working with files. And then if we open problem 2, we are going to be working with a list of temperatures, a bit similar to what we just saw Dave do, classifying them in different classifications. So you would be using both loops and else if statements here to classify the different temperatures and provide different outputs. And then in problem 3, you will be working with some lists about locations in Finland and classifying them. So you will be getting a range of latitude and longitude coordinates and a list of station names and classifying them where in the country they are located. Yes. And then you would also be, in the end, classifying them and calculating the percentage of how many stations there are in each of the different zones of Finland. So those were the 3 mandatory problems. And then the fourth one, which is optional, but is a fun exercise that I recommend you to do. It will give you the chance to show your understanding of for loops, and we will be here printing out this flag using for loops and looping over that to produce that result here. So that's a fun last exercise that you can do if you want and have time. But yes, keep in mind your readability of your code and the style guide, and then working in pairs, try to, as early as possible, communicate how you want to work together to solve this week's exercises. Are there any questions? If not, did you have anything to add, Dave?
No, I mean, thanks, Håvard, for the overview of the exercise and for presenting the good coding practice for this week. I don't think I have anything specific to add at this point. I'm trying to remember what it was that we mentioned at the beginning we could come back to because I should remember what that was, and I don't recall at the moment. There was a question, I think, related to some of the feedback in the polling questions at the beginning, so maybe I could take a quick look at that. Let's see if I can find what it was. The picture adding exercise.
Yeah.
Yes. So there is no need to stick around if you don't want to, but if you'd like to see how to add a picture, we could, for instance, demonstrate that. But yeah, I mean, I think if you want to stick around to see how to add a picture, for instance, in using Markdown, we could show that. Otherwise, you're free to go at this point, and we'll see you in the work sessions, hopefully, either in person or online. You should be able to sign up for the sessions in the spreadsheet that is available in Slack for the physical attendance of this work sessions. As far as I know, I think the capacity for the room has not changed, even though the university's guidelines for the COVID restrictions have been modified slightly. I think we're still not able to have more than 50% of the capacity of the room, which I think is what the current capacity is set to. But yeah, I can maybe share my screen again for those who are interested about this picture adding exercise. One thing I'm realizing I don't have is my GitHub credentials cached in here in the CSC notebooks, because I'm personally working on my own computer normally. But let's start with the simple thing. So we have here, let's actually make ourselves a new notebook. And that's fine. We'll add a markdown cell here, and we can say adding a picture in Markdown as our heading. And so here's how we can add a picture or a photo using the URL of the photo. And the basic syntax is very similar to how you would add a link. So it's similar to adding a link, and let's go here and just do a search for Markdown. So syntax. So we have the Markdown syntax. So here's a basic Markdown guide at markdownguide.org. I don't know this website at all, but we'll just copy this as an example and go back to wherever our demonstration is here. So adding a link, you would normally do in Markdown a square bracket around the text that you want for your link, and then in parentheses, you would have the link itself, so that when we run this Markdown cell, we say, here's how we can add a photo using the URL of the photo. The syntax is similar to adding a link, and now we have a link that should point to this Markdown guide that we had before. So just again, to demonstrate, the text that you want to put in this case would be wrapped in square brackets, and then in parentheses, you would have the link or the website that you're linking to itself. Now, in our example, we want to add a photo. And the syntax is actually very similar. We'll use this Markdown cell underneath here. And here is a photo. And basically what you do is you have an exclamation mark, a set of square brackets, and then parentheses. And the exclamation mark here is indicating that this is not a link to a website, but rather a link to some other thing like an image. And the text that you put here is just the alt text that would be displayed if the image fails to load, for example. So it would say my photo in place of that in text. if it can't actually load the photo that you would be putting in here. Now, for the photos themselves, there's lots of different places you could potentially find a photo online. A common example would be, let's open another tab here and go to Wikimedia Commons. So this is a site where a lot of the Wikipedia images and things like that are hosted, and let's pick our dog as the thing we want to search for. And then what we would need to do is take a look for the photo that we're interested in linking. So let's look for a nice looking dog photo. This one looks kind of crazy, so we can maybe skip that dog. How about this portable dog here, this French bulldog in the life jacket? Now, to be totally fair, what we should be doing here is checking what the permissions are for using this photo. If we're going to share it in one of our repositories, it's good to know whether or not we need to have attribution of where we found the photo. In this case, you can see it's Creative Commons 0 as the license, public domain dedication, which means the photo can be used without any restrictions. So I can click on the link here. I have this nice French bulldog, and then I have a link here to use this file on the web, which when I click on that, brings up the page URL for the photo. The file URL is what I'm actually interested in itself. So I can then copy that in this example and go back to the notebook we're working in and paste this in here. So now what should happen is that this photo that we're linking should now appear in the page, finding the photo from the Wikimedia website. So if I run the cell, sure enough, here comes our portable French bulldog in his life vest. So that's one way in which you can do things. The other option is a little bit harder for me to demonstrate in the sense that I don't have my access token handy. I could try and get that off screen. And let's see, maybe I could, I guess I'm going to need to get out of this directory to someplace like my exercises directory. And then what I'm going to want to do is clone a repository. And in order to clone an exercise repository, like for instance, exercise 2, I suppose I also need to click the GitHub Classroom link to create my copy of that exercise. So let's go here to the course page. I'll go to exercise number 2. And then I will create my copy of the exercise here. Accept the assignment. It'll take a moment for that to happen. And while that's happening, I will go here and try to find my access token off screen. I think you shouldn't be able to see what I'm doing. And personal access token for GitHub. I think this one should work. So what I want to do now is I've created my exercise. Hopefully I'll refresh the screen. There it is. So I'm going to go here to my GitHub Classroom copy of exercise number 2. I'm going to copy the link as we have done before. And then I'm going to go here in my exercises folder to the Git extension and do clone a repository. Paste that in here and hit clone. It's going to ask me for my username and my personal access token, which I will hopefully copy the right one. Let's see. Nope, didn't like that one. I have a few of them, so let's see if this one wants to work. Nope. Do I have the right username? I think I do. Let me try another token here. I think this one should be working. I should delete the old ones that I've disabled. Come on now. There we go. Okay, I found a working token. So now I've cloned my exercise number 2, which means I can do things like add files, add links, and whatever. So I'm going to make a new, new notebook here first. And we'll just call it untitled for right now. I'll make the first cell a markdown cell. And then I'm going to go ahead and add a directory here. And just to be consistent, I'm going to call it IMG, which is where we tend to put image files. And then I've got a new directory where I should put some kind of photo. So in this case, I have this French bulldog photo that I know is okay to download. So I'm going to download a copy of that. Let's take it at some reasonable size. So there's my French bulldog. This is going to become a little bit more of a pain than I was anticipating, but I'll save the image first. I'll just put it in my downloads folder. And what I need to do here, because I'm working on my computer, is I need to go to GitHub to my Geo-Python 2021, and then exercise 2 to my copy of the exercise. The thing that's the issue here is I want to be able to add this file to my GitHub repository, which is a little bit tricky to do from the CSC notebooks itself, because I've downloaded the file locally to my own computer. So what I'm going to do here is I'm going to, I guess, just drag and drop a file here as the fast way to upload this. This is not ideal, but I'm just going to drag and drop my image. I just downloaded this French bulldog, add dog as my commit message, and commit the changes. So I won't worry about the fact that I haven't put this in the IMG directory. That's no problem. So I have now this picture that I've dragged and dropped to my GitHub repository because I downloaded it to my own local computer. That's how I decided to handle it, was just to drag and drop. And if I go back to my notebook I was working in here, the first thing I want to do, because I've made a change to something on GitHub, I'll just go here to my Git extension, and I should pull my changes because I've uploaded the file to GitHub. It's not yet on the CSC notebooks, so I need to pull down the changes from GitHub. I haven't cached anything. So in continuing with this excellent demonstration, I need to now go and get my my personal access token again. So I'm pulling down the changes. If I look at the files now, I can see my French bulldog, and I'm going to move that into the image directory. And then I'm going to go here to my notebook and say, here is an example of a local image in Markdown. Same basic syntax, exclamation mark, square brackets, parentheses. French bulldog, which we'll just put in for the description text. And then here I need to give the location of this file relative to my current location. So this notebook is here in the Dave Whip exercise 2 directory, but our file is in the IMG directory. And I actually need to go here and find out what the file name is. Oops. I'm just going to pretend like I'm going to rename it, but actually just copy the name that's already there. And that should go in here as French bulldog in life jacket. And when I run this cell, we see locally that now we have our dog inside of the Jupyter notebook here. In order for our changes to show up on GitHub, we need to now save the changes that we have made. And so for one, we have moved our French bulldog. GitHub sees that it's been deleted. So we're going to add the version here that's staged as a moved file. We'll add the version that's changed. So what's happened now is it notices the R, so it's renamed the file from one location to another. And then I'm going to add this untitled notebook that we've just been working in so far. So we have two files staged. I'll now commit these. Add example image in notebook and move photo. Commit that. I've got to give my name and email address. And I'm sure I'm going to get prompted. No, I didn't have to push, or didn't get prompted to push. Well, no, right now I don't have to get my prompt to commit. I will get prompted for my credentials to push my changes because I haven't cached things. Copy my personal access token one more time. Paste that here, and my changes are now going to get pushed up to GitHub. And if we go to my exercise 2 directory, we would see now, if I refresh, I now have my untitled notebook. I now have this IMG directory here. And if I click on my untitled notebook and in the preview, I see my dog picture didn't show up for some reason. Why is that? I don't know. It should be the case that the picture should be visible. It might be that it's actually having an issue with resolving the location of the file on GitHub, in the sense that it should be able to find the file. I don't know why not. It can see it perfectly fine here. And I just linked to its relative path, so I'm not totally sure. This is the notebook. For some reason, it didn't actually include the... Okay. All right, 1 second. So we had a little issue here that when I saved the notebook, or maybe I didn't save the notebook, it did not include the actual path to this file. So, okay, I now have saved the notebook, save. It sees it as changed, add it to be staged, fix typo, commit, push, enter my credentials, which would be a lot easier if I had cached them. Pushes the changes to GitHub. We go here to the repository that we were looking at before, exercise number 2. And I sure hope that when I go to this notebook, I see a dog, but I still don't for some reason. Why not? We have the path to the dog. I'm not totally sure why it's not showing up in the GitHub preview, but the file has been uploaded. And yeah, it looks like there are some others who have had the same kind of problem in last week's image or last week's exercise. It's sometimes an issue with the way in which GitHub stores files, that things are not in exactly the same structure as the same structure in terms of relative paths and locations of files as they are in your repository. But if your file is not showing up, for instance, here as you might expect it to, that's not necessarily a problem. We would be able to take a look at the notebook itself and see. Same problem, picture didn't show up in GitHub, but within the code cell it worked just fine. Yeah, so I thought this normally would work. It looks like several of you experienced the same problem. I'm actually not sure, to be totally honest, why it's not working here. I thought that I had done this before with other example files and it was showing up just fine. Because in here, in this directory, we definitely have the file present. And according to the notebook preview, it should be visible here. And it does look like my fixed typo changes did get pushed. So that's a bit odd. Yeah, I don't know. I'm sorry. I don't know if I have a good solution for this at the moment. I was expecting to see the picture show up because we have plenty of other examples of files that we're using for the course where there are files in notebooks and they show up just fine. If you look, for instance, even at some of the exercises, occasionally there'll be a file or an image that's linked there. But yeah, it does look like it's a common issue according to the chat. And I think this isn't the first time I've seen weirdness with the previews of notebooks in GitHub. If we gave an absolute path to the location, so if the image is dragged into a markdown cell, it will be shown in GitHub. Okay. So that's apparently one possible solution. But basically the point here, I think, is that GitHub is looking at one location to try to find the file, and it may not actually be the case. If I just hide this meeting control bar for just a second, what we're looking at here is the pathway to this notebook. And if we were to, for instance, look in the image directory here, and then I don't know if we can even see this. The link to this file does look like it should follow the same relative pathway. It might be something in the way in which the files are hosted on GitHub when it does the preview that it just doesn't show up. So I would advise you actually, like, for those who did things in this way, that is the right way to do it as far as the notebook goes. And if it doesn't show up in GitHub, it's more likely an issue with the way in which GitHub is rendering the notebook than necessarily a mistake in what you've done. If you were able to have the file, as long as you push the image file to GitHub, and if you have a copy of the file in your repository, then it should show up in the notebook, which is the main thing for when we're doing the grading, is whether or not some picture is available in the notebook. We pull down all the notebooks ourselves, the copies of them, so we don't necessarily look at the GitHub preview as the main way to take a look for things like an embedded image. So sorry for going over the time a little bit and for actually not being able to successfully demonstrate how to do this. But the GitHub preview of notebooks is a little funny. And I think in this case, this issue of not having the image appear is more than likely an issue that has to do with the GitHub preview, not a problem with the notebook, because the notebook itself, where we've embedded the image, everything has been done properly. So for instance, here it shows up just fine in the notebook. And if we look at the list of files that have changed or that are untracked, there's nothing here. All of the changes have been pushed to GitHub. So yeah, sorry to not have a better demonstration of that, but we will keep this in mind when the assistants are looking at the notebooks to make sure that they actually check the notebook itself, not the GitHub preview. Are there any other questions? I know we're a little bit past the time, so. If there's nothing else, then yeah, thanks for the good interactions today, as close as we can come to sort of feeling like it's sort of interactive environment. So appreciate the questions and feedback, and we will see you guys in the exercise sessions and in class next week to talk about functions.